Hello, we're going to do it says problem 1, pomp and circumstance. This is on page 228. And again, if you're going to give me this paper, you need the name, date, and period. So make sure you stick that on the paper so when you hand this thing in. Now there's not much going on in the back, and you could answer this question down here as well. But I'm going to focus on the solution for here. So it says find the area and the perimeter. Well, they did us a favor. They plotted the points and they labeled the points. And so I'm going to find the area first. Now, it looks as if this might be a square, but I'm not sure. So let's see if I can figure out the area of this shape. If it's a square, I just need one length, base times the altitude. So let's see, a couple ways. I could use the box out method. If you watch the other video, I could use the slope method. Okay, so the slope method would say, I think that's a right angle. And we can kind of see using anything shaped like, yeah, it definitely looks like one, so we could figure out if it was. Then we just need the base times the altitude, okay? So I think slope method actually might be shorter. So I'm going to do it that way. So I'm going to calculate the slope looking at the problem. So let's see. I could use the two coordinates. So the slope, if I knew what this slope B and C was. So the slope is y2 minus y1, x2 minus x1. So, okay, so I take 3 minus a negative 2, 3 minus a negative 2, right? The y minus the other y, and then the x minus the other x, the x minus the other x. So I rewrite that, and I get 5 over negative 12. Okay, so I can think of that, this fraction is negative. So the slope's going down, which we already see that. And so it looks like I'm going down 5 over 12. Okay, and so if this line really is perpendicular, I'm looking for a slope that's positive 12/5. So if my slope is positive 12/5, so I see I flip the sign and flip it upside down, then it will be the perpendicular slope. So let's take a look. Using the same technique, it looks like I maybe went up 12 over 5. It looks basically the same distance, but let's use the coordinates to be sure. So if I'm going to go from B to A, let's zoom in. I want to use this same formula. So slope from B to A would be take one of the y's and subtract. So it actually makes more sense to take 15 minus 3. So I'm going to do 15, subtract one of the y's from the other y, then subtract the x from the other x. Okay, so 15 minus 3 is 12, and 2 minus a negative 3 is 5. Oh, yeah. So here's awesome. I've actually confirmed that these are perpendicular, so that's definitely a right angle. Now I can keep going. This looks down 5 over 12, and this also looks down 12 over 5. The one thing that makes this problem a lot trickier is notice each box is worth 2. So that's very important. It makes it harder to kind of get in the car and drive because each box is worth 2. So it looks like this is 6 boxes, but that has to be 12 because each box is worth 2. Notice that 2 boxes is a 4, which means they counted 2, 4, 6, 8, 10, 12. Okay. So now I've confirmed that's a right angle. I actually confirmed that's a right angle and that's a right angle. So to find the area, I could either think this is a rectangle or a square. But I'm noticing this is 5 and that's 12. This is 5 and that's 12. This is 5 and that's 12. So if I really do get in my car and drive 5, get in my car and drive 12, I can find the length of this line right here by doing 5 squared, 12 squared. So as long as you can drive, keeping track that each box is worth 2, I can get in my car and drive 2.5 boxes, which is 5, right? 2, 4, and then 5. And I drive 2, 4, 6, 8, 10, 12. So same thing here. This length would be I drove 5 and I drove 12. So to find that length is 5 squared plus 12 squared. I'm going to do it again. I can drive from -3, right, to 15. That's definitely going to be 12 and 5. So this length is the square root of 5 squared plus 12 squared. And one more time, this would be 5, that would be 12. That's definitely the square root of 5 squared plus 12 squared. Okay. So this thing is definitely a square because any object that has a 90-degree angle and that all of these are the same length, that is definitely a square. And the area of a square is just base times height, or base times altitude. And these are going to be the same number. So let's calculate that. I take 5 squared is 25, 12 squared is 144. I add them up and I get 169. Now you're in luck. The square root of 169 happens to be an actual number 13. So this length is 13, this length is 13, this length is 13, this length is 13. So the area here would be 13 times 13, which is 169, and I'm just going to call it inches squared. Okay, so I've found the area. Now can I find the perimeter? So I get that this is confusing because I ended up using Pythagorean theorem to help me find the area here. But perimeter is if a shape has 4 sides, I'm going to add up all 4 sides. And I'm just adding up all those numbers I just highlighted. So my perimeter of a 4-sided shape is to add up all the numbers. Now using Pythagorean theorem, we calculated this to be 13. This would also have to be 13. This would have to be 13, and that would be 13. So 13 and 13 and 13 and 13. 2, 3, 4, 5 inches. Great job. Now, I'm just going to review, same problem. I'm just going to review what we did in class. I can use Pythagorean theorem to find the perimeter. I went over 5 up 12. So I put 5 squared, 12 squared, and took the square root. When I simplified this, not always, but in this case, I got a number 13. So I know the length of the yellow line is 13. I do it again. I went up 5 over 12, and I got exactly the same thing. This would simplify to the square root of 169, which happens to be 13. And then the same thing happened again, and then the same thing happened again. And I should not be surprised by this because it definitely looked like a square, and a square has 4 equal sides. So when I use Pythagorean theorem to find the perimeter, I get 13 and 13 and 13 and 13. So you might be thinking, why did I use the slope method? I needed that because I need an altitude. And unless the picture's laying perfectly on the box, I can't assume that that's a 90-degree angle. So I needed this slope method just to confirm that that is perpendicular. So those coordinates definitely had a slope that was the opposite reciprocal. All right, so I'm going to write opposite reciprocal. Thanks for joining us. Check out the other video for problem 236. You had 2 problems.